Hello students, this is Vyan Sharma. I hope you all are safe and doing good. In the last lecture, I had discussed about different states of matter. Mainly, the three states which I had discussed were solid, liquid and gas. I also discussed about the properties of each state in detail. So today, I will be discussing some important concepts related to the change of state of matter. So the first question in process is, can matter change its state? So in order to explain this whole concept, I would like to discuss kinetic energy in more detail. So in the last lecture, I had also given a statement that the energy possessed by the body due to the virtue of its motion is known as kinetic energy. For example, if I'm running, so that means I am gaining kinetic energy, right? And if I am decreasing my speed, then I am losing kinetic energy. Similarly, if you turn on your fan, then the blades of fan will gain kinetic energy. If you are driving a car, that means car has kinetic energy. So anything which is in motion contains some amount of kinetic energy. Similar to that, atoms and molecules which make complete matter, whether it be a solid, a liquid or a gas, are present as the layers of matter. So whenever any external energy supplies on matter, these atoms starts exciting, and when they starts exciting, they gain some kind of kinetic energy. Let's take an example of boiling of eggs. You might have seen the process of boiling of eggs. So what happens when we supply some amount of heat from the burner or the flame? It appears that the eggs are some kind of jumping. So what is that process? In that process, the eggs are gaining some amount of kinetic energy. So I hope you have understood kinetic energy now. So whenever a solid is supplied with a temperature, it gains some amount of kinetic energy. Why it gains some amount of kinetic energy? Because the kinetic energy of each and every particle of the solid increases. Every particle becomes excited. The particle starts kind of jumping. That means the kinetic energy of particles start increasing and the particles start vibrating, similar to as the vibration of your phone, with greater speed. Right? So why they are vibrating? Because you have studied that matter have force of attraction between its particles. So whenever we are supplying kind of temperature, the temperature is trying to overcome this force of attraction. So the particles are trying to separate from each other, but due to force of attraction, they are not easily separable. That is why they are vibrating first, and then they are moving. So this is the concept of effect of temperature on matter, particularly on solid, that we discussed. And this is the concept of kinetic energy and the increase of kinetic energy. So you might have seen the three states of matter of water, that are solid as ice, liquid as water and gas as water vapor. So we already have noticed about three states of water. So we can say that yes, matter can change its state. But does matter change its state automatically? No. It changes its state after gaining some energy. That energy can be supplied by temperature, can be supplied by electricity or by any another medium. Right? Now, the state of conversions are solid, liquid and then gas. So in activity 1.12, you need to take some amount of ice in a beaker and then you need to increase the temperature from the bottom. You need to put a thermometer to note down the temperature after certain intervals of time, and a glass stirrer is used to stir the solution, or you can say the water, when it melts. So you'll see that after some time on increasing the kinetic energy, as we discussed, the particles of ice will start vibrating, and after a certain interval of time there will be a stage after which this solid ice will start melting to become liquid at atmospheric pressure. So this process is known as melting. So the melting point is also an indication of what? Of the strength of the force of attraction between the particles. Try to understand it. The more the melting point, the more will be the force of attraction between the particles, and it will be tough for the solid to get melted. Now, the melting point of ice is 273.16 Kelvin, or you can say around 0 degrees Celsius. That means when solid is turning into liquid, the point is 0 degrees Celsius from where the process start taking place. But you might have observed, when a solid melts, its temperature remains same, and melts at this point, its temperature remains same for a particular interval of time. The temperature will not exceed, and the solid will keep on changing its state from solid to liquid. So where does this heat go? Why the temperature is not increasing at all? This is the question. So as this heat energy is absorbed by ice without showing any rise in temperature, it is considered that heat gets hidden into the contents of the ice, or you can say into the contents of the beaker. And since this heat is hidden, it is also known as latent heat. That means hidden heat. So at latent heat, at this point, the solid is converting into liquid without actually increasing the temperature. That is why it is known as latent heat, or you can say the hidden heat. The concept of latent heat is an important concept. I want you to read this concept from NCERT thoroughly so that you can understand it in a better way. Try to see this whole video session for at least 2 to 3 times in order to understand the concept properly, because it may be possible that you may not understand it for the first time, but after watching the video for 2 to 3 times, you can easily relate to the concepts, and you must read NCERT for that. So this type of latent heat which is required to melt the ice into water, or you can say into liquid, is known as latent heat of fusion. So we turned from solid to liquid with the help of melting and with the help of this latent heat of fusion. Now it's the turn to convert the liquid to gas. So when we supply heat energy to water, in this state the liquid is water obviously. So when we supply heat energy to water, the particles will move even faster. Now why they will move even faster? Because liquid have less force of attraction between its particles comparative to that of solid. Solid have more force of attraction between its particles because they are very close to each other. Let's say these are the particles of the solid, then these will be approximately the particles of liquid, in which there will be more gap. So since the gap is larger, they'll move even faster. That is why liquid travels faster. Again, at a certain temperature, a point is reached when the particles have enough energy to break free from the forces of attraction of each other. So at this temperature, where they are breaking the forces of attraction, the liquid start changing into gas, and the temperature at which liquid start boiling, right, at the atmospheric pressure, is called boiling point. Again, there will be some latent heat which is present there from turning the liquid to gas, As when the liquid is turning into gas at a particular temperature, the temperature will not increase and the particles of solid will continue to turn into particles of gas, and the particles of liquid will continue to turn from liquid to gas. Now this point at which the particles in steam now have absorbed extra energy in the form of latent heat. This point at which the particles in steam have absorbed extra energy in the form of heat. This point is related to latent heat of vaporization. The boiling point of water is 100 degrees Celsius. So the process is taking at 100 degrees Celsius. This process was taking at 0 degrees Celsius. So you need to relate the concepts. Here you studied the melting. Here you are studying boiling. Here you studied the latent heat of fusion. And here you are studying latent heat of vaporization. That is why steam is more dangerous. So there is a question why the burn from steam is more dangerous than that of liquid. So from here we can infer that matter can change its state. Now this whole concept is related to the effect of temperature. Now we'll be discussing effect of change of pressure. So as you know that the particles of solid are very close to each other. The particles of liquid have space between them. The particles of gases have more space between them. So if we will increase the pressure, the particles of gas will come together as we are increasing the pressure, right? We are trying to compress it. And if we are increasing the pressure here, the particles of liquid will get more closer to each other. So on compressing gas it can be turned into liquid, and compressing liquid it can be turned into solid. That is why we are studying the effect of change of pressure. Applying pressure when you are increasing the pressure and you are decreasing the temperature can liquefy gases, and this concept is used in liquefaction of gases. So when you are decreasing the temperature, what happens when the temperature decreases? Our body contracts. So when we are contracting and the pressure is increasing, we are occupying less space. So we are getting congested. And if we are getting congested, that means we are getting close to each other. So increasing pressure and decreasing temperature can liquefy gases. Have you heard of solid carbon dioxide? Yes, it is stored at very high pressure and low temperature, and solid CO2 gets converted directly to gaseous state on decrease of pressure without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice, because it turns from solid to gas directly. There is also a process in which a solid can turn to gas without changing to liquid. So this process of turning of solid directly into gas is known as sublimation. You must know about the processes. The melting, boiling, sublimation. You must know about every process. So now let's discuss the figure 1.9 which is present in your NCERT and on your screen also. Here, first of all, liquid is at the top, solid is on the left, gas is on the right. So the process of turning of liquid into solid is known as solidification. From solid to gas is known as sublimation. From gas to liquid is known as condensation. Similar to that, from solid to liquid it is known as fusion. From liquid to gas it is known as vaporization. And from gas to solid it is known as sublimation. So these are the interconversion of three states of matter, right? So you must remember this diagram. You must make this diagram on your notebook so that you can understand it properly. So now I want to ask a question. Do we always need to heat or change pressure for changing the state of matter. Or sometimes in everyday life, there is a change of state from liquid to vapor takes place without the liquid reaching the boiling point. Can you quote any kind of example? Can you quote any such example? I think there is an example which relates to everyday life. Water, when left uncovered, slowly changes into vapor. Wet clothes dry up. We are not deliberately heating, but the conversion of liquid to vapor is taking place automatically below the boiling point, right? So this process is known as evaporation, the phenomena of change of a liquid into vapor at any temperature below its boiling point is called evaporation. This is a very important concept. You must know the difference between boiling and evaporation. So boiling can be done at the boiling point only, while evaporation can be done below the boiling point. The process of conversion of liquid into gas is taking place automatically. Now let's discuss the factors affecting evaporation. In that, the first factor is surface area. So what happens when you are increasing your surface area? Suppose first of all you are taking some amount of water in a bowl, and then you are taking some amount of water in a bigger bowl, or you can say in a plate. What happens? You are increasing the surface area. So if you are increasing the surface area and you have taken hot liquid, it gets cooled fastly in a larger bowl or in a larger plate. Why? Because the rate of evaporation increases. So when you are increasing the surface area, the rate of evaporation is increasing. You can say that surface area is directly proportional to evaporation, or evaporation is directly proportional to surface area. Now, when you are increasing the temperature, again, more number of particles will get kinetic energy. Therefore, the liquid will fastly convert into vapor. So increase of temperature is also directly proportional to evaporation, or you can say the rate of evaporation. Now what happens when humidity is increased? You might have noticed that during rainy seasons, the clothes takes more time to dry up. Why? Because the humidity in the atmosphere is very high. So the atmosphere already contains the droplets of water in it. Therefore, the amount of water in air is already high. The rate of evaporation decreases. So humidity increases, rate of evaporation decreases. So we can say that humidity is inversely proportional. Let's write here. Humidity is inversely proportional to evaporation. We can say evaporation is inversely proportional to humidity. Now, wind speed. So it's a common observation that clothes dry faster on a windy day. With the increase in the wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. That is why the evaporation, or you can say the rate of evaporation, is directly proportional to the wind speed. So these are the four factors. Let's conclude again. Evaporation is directly proportional to surface area. When the surface area is increasing, the evaporation rate is increasing. Is directly proportional to temperature. When the temperature is increasing, the rate of evaporation is increasing. Is inversely proportional to humidity. And when the humidity is increasing, the rate of evaporation is decreasing. And is directly proportional to wind speed. So this concept is also very, very important. So the next concept is, how does evaporation cause in cooling? So in an open vessel, the liquid keeps on evaporating. We have discussed it earlier that in an open vessel, the liquid keeps on evaporating. Particles of liquid are absorbing energy from the surrounding to regain the energy lost during the evaporation. Why? Because these particles wants to maintain their energy. So whenever they are evaporating, also simultaneously the particles are trying to gain some energy from the surroundings. So this absorption of energy from the surrounding makes the surrounding cool. The surrounding becomes cool in this process. Why? Because the energy of the surrounding is getting transferred to the energy of liquid. Let's take some example if it is difficult to understand. What happens when you pour some amount of acetone, or you can say nail polish, on your palm? On the top of your palm, if you pour some nail polish, the particles of nail polish will gain energy from your palm. So it will lead to evaporation, causing the palm to feel cool. So your palm becomes cool and the liquid becomes warm. Let's take another example. After a hot sunny day, people sprinkle some amount of water on the roof or open ground. Why? Because the larger latent heat of vaporization of water helps to cool the hot surface. So it takes the energy from the hot surface and make the hot surface cool. There are n number of examples of evaporation which can cause cooling. This is a question for you. Why should we wear cotton clothes in summer? There is another question also. Why do we see water droplets on the outer surface of glass containing ice cold water? You must have noticed it. If you pour some amount of ice cold water in a glass, you will see some amount of water droplets outside the glass. Why do you see those water droplets? I want you to answer all these questions. I want you to study how does evaporation cause cooling from NCERT in detail. So in this chapter, first we discussed about the existence of matter. We discussed the theories related to the existence of matter, related to the composition of matter. Then we discussed about the states of matter and their properties. After that, today we discussed about the change of state of matter. Then we discussed evaporation, effect of temperature, pressure, and how evaporation causes cooling. I want you to make notes of the chapter, your own notes, so that you can understand the chapter more clearly. Then I want you to solve the in-text questions of the chapter. I want you to solve the exercise questions of the chapter, and I want you to answer all those questions which I had asked during the video sessions. I also want you to focus more on the activity parts of the chapter, because activity contains a lot of concept in it. That is why I want you to read them also in detail. So this is all about this first chapter, in which we discussed about the matter present in our surroundings. So thank you for watching all the video sessions related to this chapter. I want you to watch them again. You have a lot of time, so you can watch all those video sessions together now in order to relate each and every video session. In this way, you will understand the chapter clearly and you will have no doubts left. And if you have any kind of doubts, you can ask in the comment section. You can ask in the WhatsApp group which we have made for your separate classes. So this is all about today's video session. Thank you for watching this video session. Please be safe, keep studying, and be at home. Thank you.